Hello, everybody, and welcome back to Geography 340 Climatology. My name is Zach Hilgendorf, and today we are going to be talking about the drivers of global climate differences. And we're going to start off with the most important one, latitude. Solar radiation varies with latitude. Depending on the season, depending on your position on Earth, you're going to have a different solar angle and therefore different solar radiation. It's the greatest cause of global temperature differences. But places along the same line of latitude are generally going to have the same climate with obvious variations that we'll get into here in a little bit. But have a fun question. Any wine lovers? Think of some of the most prominent regions for grape growing and wine production in the world. The Bordeaux region in France, the Willamette Valley and the Pinot Noirs that come out of the Willamette Valley. Even here in our own state, the Door County area has some of the best and most diverse vineyards. And anyone know what parallel those fall along? Well, they fall along the 44th parallel line or the 44th latitude. And obviously similar on the south side of the planet, but all of them fall along that typical 44 to 40, I'd say mid 30s to mid 40s latitudinal lines. If you think of the Sicily region in Italy, also that's around 37. The Niagara region, the Traverse City region in Michigan, all of these really prominent or iconic growing areas, same for beer, all fall along kind of these mid-latitude lines. Next, we're going to talk about land and water. So this is second only to latitude as a controller of global temperatures. So if we think back to our intro to physical geography classes, water has a greater heat capacity than rocks or soil. Land is going to heat more rapidly and cool more rapidly, and it's also going to heat hotter and cool colder. Marine climates are typically mild for a given latitude because of the moderating effect of a large body of water. Even on the Great Lakes, along the Pacific and Atlantic, anywhere you have a very large body of water, those coastal areas are going to have a much more moderate climate than an interior region with the same line of latitude. Continental climates are more extreme. Think of Eau Claire. We go from, negative 40 sometimes in the winter to, 30 degrees C in the summer with high humidity. But even here in our own state, areas along Lake Michigan are going to have a much more moderate climate than we actually have. These two pictures on the left here are generally around the same latitude. One of them is from the coast of California, kind of more of the southern to central coast of California. The other is from the interior of Arizona and kind of the middle north portion of Arizona. And they're vastly different in vegetation, soil, precipitation, and temperature regimes. Next, we're going to move into geographic position and the prevailing winds. So depending on your position on the continent, whether you're in the windward or leeward position of the kind of dominant global winds like the westerlies or the trade winds, this will have a dominant effect on your climate. So winds, for example, can carry maritime air masses much further inland. Or if you're on the leeward side of a continent, you can have a much more continental climate regime. So if we think of just our own country here in the United States, we have the Pacific coast, and then you've got the Atlantic coast, and those are two vastly different climates. And other things play effect to that as well, such as ocean currents. But for the most part, these along one continent have drastically different temperatures, even though they're both along major bodies of water. Then the next big impactor is mountains and highlands. And they play a really important role in climate distribution. So they serve as a boundary to winds and moisture. And again, if we're thinking back to our intro to physical geography courses, they impose an orographic effect. So essentially, as we see in the diagram here on the right, as air masses come in off the coast, for example, and they encounter a mountain, they rise, that air cools, water condenses, and rain falls out, or snow in some cases in your higher elevation regions. But when you're descending, you have a descending air mass, that air is heating at a much faster capacity, and there's no moisture left. The moisture has been rained out. You have this rain shadow effect, pardon me, on the leeward side of major topographic barriers. Ocean currents are the next big thing, and I mentioned this a few slides ago. Ocean currents can have a really big effect driving temperature differences. So if we think of the cold California current that comes down from the North Pacific versus the warmer Gulf Stream current that comes up from kind of our more northern equatorial regions, those have a pretty big effect on the moderating effect of climate or of water on temperature, and also have a big effect on the types of flora and fauna that inhabit those different oceans. So there's that climate as well. But depending on where you are and depending on which type of ocean current you have, there's a very moderating effect that they have on your temperatures. And then finally, pressures and wind systems. So global precipitation very closely follows major pressure and wind setups across the globe. In equatorial low pressure regions, you have the convergence of warm, moist, and unstable air that leads to a lot of heavy precipitation. Think about where some of our tropical rainforests are. They're in that equatorial region. In our subtropical high pressure areas, we typically see a lot of aridity. That's where our prominent deserts are, sub-Saharan Africa, getting into kind of the southwest of the United States, the outback in Australia, etc. In the mid-latitudes, you'll have traveling cyclonic disturbances that will increase precipitation. So what we call mid-latitude cyclones that we'll get into towards the end of the course, but we'll talk about how those set up and drive precipitation. And then near the poles, obviously it's colder, but if you think about it, there is not as much moisture capacity in the air. So you actually have rather dry and arid climates. So the temperature and moisture capacity of the air are low there. So that kind of sets up some of the dominant drivers of global climate. And how do we make sense of all of this variability? Well, that's going to be for the next video. In the next couple of videos, we're going to talk about climate classification and the distribution of climate regions across the globe. So looking forward to chatting at you again here real soon, and I hope you enjoy the video. Thank you.